Good morning, everyone. Today we will be presenting a comparative analysis of two popular DAC architectures, the R-2R ladder and the R-string DAC. We will look at how both architecture function, their advantages, drawbacks, and how they compare in terms of performance parameters like linearity and complexity. Next slide, please. Before we compare architecture, it is important to understand why DACs are so essential in electronics and communication systems. In real world, all signal like sound, light, and temperature are analog. But most of our modern systems like computer, smartphone, and digital instruments process data digitally. So to interact with the real world, we need a bridge between digital to analog domains. And this is exactly why DAX or digital to analog converter does. In short, DAC plays a crucial role in ensuring the digital signal we process can be accurately represented and used in analog world. Next slide, please. Avinash. Avinash.
Sorry. Thank you, Ayush, for explaining this. Now I am going to explain the R2R ladder DAC. Let's start with R2R ladder DAC. This architecture uses a binary weighted register ladder composed of register with values R and 2R. It's compact design that require only 2n register for n-bit DAC, making it very scalable and efficient. The challenges in this architecture, the mismatch introduced INL and DNL error, especially at higher resolution. Parasitic effect degrades performance. Its strength is a minimal component compound count, low power consumption, and scalable for CMOS integration. It is best for compact designs, low power applications, and moderate linearity requirement. Overall, uh, previous slide, please. Ayush, yes. Overall, R2R DAC is best suited for compact, low power design where moderate linear is acceptable. Next slide, please. We have the R string DAC, also known as the register string DAC. This architecture uses linear register chain with equal register and the digital decoder that selects specific tab points to generate the analog output. Its biggest strength is inherent monotonicity, meaning the output voltage always increases with input code. It's also provide lower INL and DNL errors and excellent linearity. On the downside, the challenge is scalability. So the R string DAC is a best for higher accuracy and stable output applications, especially at the lower resolution. Next slide. Yes, yes. Now moving 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 to the key performance matrices. Lastly, let's look at the key performance. uh, INL is integral non-linearity. It's measure how far the actual output divides from the ideal transfer curve, reflecting overall DAC accuracy. DNL, the checks the difference between adjacent output step when the DNL stays within the plus minus LSB. The DAC output is guaranteed to the monotonic. Gain error represent the deviation in slope between the actual and ideal transfer curve, often caused by resistor mismatch and parasitic. Finally, resolution defines the smallest distinguished voltage step. It increases exponentially with bit width, following a roughly ref divided by 2n. Using this parameter, we compared both DACs and identify that R string achieves better linearity while R2R offer greater area and power efficiency. Now, simulation methodology. Uh, we implement and tested both architecture R2R and R string from 2-bit to 8-bit resolution in Cadence Virtuoso using the GPT 180 nanometer CMOS process. The supply voltage was set to 1.8 volt and 2 volt with reference voltage of 1.8 volt. And we assume plus minus 1% resistance tolerance. For our circuit implementation, both DACs were designed with identical parameters to ensure a fair comparison. Finally, we extracted INN, DNN, and gain error and also resolution for each bit width and supply condition to overall performance. Yes, please explain this.
Greetings everyone. So here we will discuss our results. So now uh, all my friends, Avinash and Ayush, they just discussed what we did in the research. Now let's discuss the results, like what we achieved from this. So here we can see that there are there are two types of results. First is linearity performance result, where we have measured linearity parameters like INL, DNL, and compared it. And when we found comparison, we can see that R-string DAC has a great performance, especially the INL DNL ratio is quite low, but there is noise in the end, means at the last bit. Meanwhile, R2R ladder DAC has moderate performance, but the key performance is quite consistent. Like in especially when the VDD is 2 volt and VREF is 1.8 volt, we get a proper ladder, and in the end we get a proper sawtooth fifth. Gain error analysis. So here we have done gain error analysis where we can see that R2R R2R ladder DAC has an issue with gain error. Means like till the end R2R ladder DAC falls short, but R string DAC has lesser gain error. So we can conclude that the final output the final output is way better in R string DAC than R2R ladder DAC. Design trade-offs and recommendation. R string DAC. We can choose R string DAC when we need high accuracy and stable output. But there is one shortcoming of this circuit. That is that it can take if we increase a lot of bits, it can have generate line capacitance. Then second one, R2R ladder DAC. We can choose R2R ladder DAC when we need compact designs and uh, low power applications, as it has less number of registers and less components. Conclusion. So in this experiment, we uh, we have tested we have tested two popular DACs, which is R string register string DAC and R2R ladder DAC. And after this, we can conclude that R2R DAC is compact and is easier to implement. Also, it gives moderate to good output for when the V reference is lesser than VDD. Meanwhile, R-string DAC gives a linear and monotonic output, a higher precision, but it requires more resistors. The circuit gets complex, and as the circuit gets complex, it introduces line capacitance into it. Means as bit increases, as the resolution increases, circuit gets complex for R-string. Meanwhile, for R2R ladder DAC, the circuit doesn't get that much complex as R-string. In summary, we can say that we can use R-string DAC for high accuracy applications and where power is not a factor to consider. Means we can use a lot of power. But meanwhile, we can use R2R ladder DAC for compact area-based low power applications. So that's it from our side. Thank you so much for listening.
Thank you, everyone.
Thank you.